Hello world! In this video, you will learn how to apply rejected inference in credit scoring. Before we start, I'm going to explain you what rejected inference is. Let me give you an example. This is Victor and Chris. They currently need some money, so they go to the bank and ask for a loan. Victor gets rejected, while Chris gets the loan. Chris becomes part of the people that gets the loan. This is known as bias or known population. This population can be divided into the good borrowers, known as known events, and the bad borrowers, known as events. This is classified based on a certain criteria. Do you remember Victor? Victor didn't get the loan, becoming part of the rejected or unknown population. The good and bad labels shown will be the target variable in our model, whereas the rejected ones have no target variable. The null population is considered as biased because of two reasons. The first one is because they have different characteristics compared to the rejected or unknown population. The second one is because they have a smaller population compared to the rejected ones. Once we have identified our biased population, we need to preselect the most predictive group variables. These group variables will be used to build a scorecard. This scorecard will be used to train the model so that we can get the new scorecard. This new scorecard will be used to infer an event or non-event. In other words, to identify the good from the bad borrowers. Trading the good for the bad ones, having as a result the predicted bad borrowers and the predicted good borrowers. In conclusion, the rejected inference is a method used for improving the quality of a scorecard based on the use of data contained in the rejected loan applications. These are some other methods used in rejected inference. The augmented methods, the fuzzy methods, the hard cutoff method, and the parceling method.
Parceling and fuzzy augmentation, which are among the most popular techniques. Fuzzy augmentation consists of developing a first model on the bias sample, so the accepted population, and use this model to predict the probability of the targets for the rejected population that we did not previously have. Once this is done, in terms of the logistics, the idea is to compute two rows for the rejected population, one row for the probability associated with the outcome is equal to bad, and one row for the probability is equal to good. And finally, once we have our new final data frame that combines applicants that were accepted with people that were rejected, but whose target variable is now estimated, we can develop a final model with the whole datasets. Regarding parceling process, it is very similar in terms of the process itself, but the only difference is that it is in the computation of the probabilities for the rejected applicants. So now we are going to simulate actually the target variable for the rejected applicants, and we are going to use this data again along with the accepted applicants in order to predict a final model. So the idea is to simulate this target variable for the rejected applicants by respecting the proportions that are inferred from the accepted applicants, so that you use a distribution that will more or less replicate this distribution of the accepted applicants, thereby making sure that you have on average a right label for the rejected applications.
Now it's time to let's do some coding.
All right, now we are gonna walk you through an example of the process of reject inference. using the augmentation techniques, which is one of the techniques among a variety of them that you can use for this subject. We're going to do this walkthrough using data provided by the company Lending Club, and they provided both for accepted applications and applicants who were rejected, unfortunately. We are going to perform this walkthrough with Python, so we are going to use a very popular machine learning library, sklearn, and I'm going to start by importing this library. So what we're going to do is that we are going to first train a model with the bias sample, which is pretty much the sample of accepted applicants, in line with what we explained earlier. And we are going to use this model that we compute on this data in order to infer the class of the rejected applicant. We're going to try to come up with the label, the target variable of those rejected applicants, so that afterwards we can compute a final model that combines both the data of the accepted and the data of the rejected applicants, in order to have a model that is more, better suited for predictions across the whole population. Of course, the question of interest is the ability to predict early on whether a person seeking for a loan will be able to repay their loan. And we are starting by importing the data. As you can see, the data of accepted applicants is around 60,000 samples. The data for the rejected applicants were around 1 million data samples. It's interesting to see the dataset itself. We of course do not focus on the feature engineering. We assume that the data is already clean. And here is our target variable, whether the applicant managed to repay or not their loan after the assigned period. We have a pretty much balanced data set with a good number of good and bad applicants. And we have the same type of data for the rejected applicants. Of course, we are missing the target variable because we cannot observe it for the rejected applicants. That's the whole point. But we are first going to try to estimate it, so that afterwards we can combine the rejected data with the accepted data to come up with a global model for the whole population that try to get loans. So we're going to start without reject inference. We are going to use sklearn, as I mentioned. We therefore instantiate our model, make sure we don't have any A left in the data, and we split our data set between train set and test sets in order to evaluate, the efficiency, the accuracy of our model. So we can very simply predict the data with sklearn again, and predict data that is in the test sets, so data that the model hasn't seen. So I'm just going to run the algorithm, and we are going to focus on 5 metrics here, with the most important one, for this very brief introduction to reject inference, the most important one is going to be accuracy, and we're going to compare, how accurate our model is. Incidentally, there is also a focus on, true positive, false positive, which is the classic evaluation tools for classification problems. And we can see that our model has an accuracy of 0.63, which is not bad. But the question is, how does this model compares to a model that we compute with the whole data with the process of reject inference? Well, we're going to do that now. We're going to move on to, first of all, predict the label, so the target variable for the rejected dataset. How do we do that? We, again, instantiate a new model, take care of the NA variable. And what we do here is we use the model that we computed, on the bias sample. The bias sample is, of course, the applicants who managed to get a loan, so the accepted applicants. We use this model to predict the likely label, to have an estimation as to what will be the target variable for our rejected applicants, because once we have this target variable, well, we're not missing it anymore. We can use not only the data from the from the accepted applicants, but also we can combine it with the data of the rejected one, in the hope of coming up with a model that's better suited for the population as a whole. Now we're gonna do two things. First of all, I'm gonna comment that out because we are gonna try to predict and evaluate how good our model performs on the test set of only biased data, so only the applicant's data. And I'm gonna run the whole thing. Well, what is interesting here is that, as you can see, the accuracy of 0.626 compares pretty well with the accuracy we got for the previous one. But of course, the idea of reject inference is to be able to have a better performing model for the whole population. And in order to estimate that, we are gonna not only predict the data that is in the biased sample, but also we're gonna now predict all the testing data. So we're going to predict data that comes from the rejected population, but also from the accepted population. And we're going to see how this new model performs, of course. So what do we have here? Well, we have an accuracy of 0.628, which is, again, pretty close to have if we were to only use our bias sample. So yeah, that is the process of reject inference. I just wanted to remind you that this is a process just to exemplify the concept that we covered in the first part of the video.
I am your Python professor.